Hey guys, what's up? Here we are with 1.4, solving with absolute value. Remember that absolute value is the distance a number is from 0 on a number line. Alright, so you got 0 here in the middle. Okay, 4 is 4 units away from 0. And guess what? Negative 4 is also 4 units away from 0. So that's kind of a way to think about that. Okay? So basically what it does, some people like to think of it as it makes everything inside positive. Okay, because you can't have negative distance. Alright, so the absolute value bars or box or whatever you want to call it kind of act like a set of parentheses as well. You do whatever's in there first. So this is 4 plus 2. Alright, inside, or 4 plus 2 times. Inside here, this is negative 2. Struggling. Negative 2. Okay, in the absolute value, negative 2 is how far away from 0? 2 units. So this is going to be 4 plus 2 times positive 2. And we'll get 8. Okay, so we did inside here first, negative 2. The absolute value bar, so it's the absolute value of negative 2? Positive 2. 2 times 2 is 4. 4 plus 4 is 8. Alright, so that's just using absolute value. Hopefully you've seen that before in Algebra 1. Okay, when solving an absolute value problem, here's the trick. This might be new. Okay, when solving absolute value problems, you need to get the absolute value bars by themselves. That's what you isolate, and then split into two different equations, one positive and one negative. Okay, why? Why? Okay, what if I had absolute value of x equals 2? Well, that x could have been two different things. It could have been negative 2, and the answer would have come out as 2. It could have been positive 2, and the answer still would have come out as 2. So that's why we have to have two separate things. Alright? So, let's see what we got here. We're going to subtract 4. So we have 3x minus 2 equals 4. Okay, so the absolute value of this mystery number in here is equal to 4. So I know that whatever is in here has to either be 4 or whatever's in here had to be negative 4 because of the absolute value of that would equal positive 4. So that's why we take whatever, you have to get the absolute value bars by themselves, and then whatever's in there is equal to that, or whatever's in here is equal to the negative of that. So we're looking for when 3x minus 2 would equal 4, or when 3x minus 2 would equal negative 4. So plus 2 plus 2, 3x equals 6, divide by 3, divide by 3. So 2 would work for us. Okay, check back up here. 3 times 2 is 6, minus 2 is 4. Absolute value of 4 is 4. 4 plus 4 is 8. That would work. What about over here on the negative one? Add the 2. 3x equals negative 2 divided by 3. X equals negative 2/3. Okay, a little bit yuckier. A little bit yuckier, negative 2/3. So 3 times negative 2/3 is going to be negative 2. Minus 2 is going to be negative 4 inside of here. Absolute value makes it back to positive 4, plus 4 is 8. Okay, so you get the absolute value bars by themselves, then split it into two equations. One with whatever's in here equals over here, and with whatever's in here equals the opposite of that, or the negative of that. Okay, now it is possible to get some no solutions. Alright, and you tell me when you know this is a no solution. So step 1, I know I got to get the absolute value bars by themselves. Minus 10, minus 10. Absolute value of 2x plus 5 equals negative 2. Stop. What did we say absolute value is? Distance from a number line, or distance from 0 on the number line. Alright, we said that absolute value always comes out as positive or 0, or positive, and here we have negative. So this is not possible to have an absolute value come out to be a negative 2. So stop right there. Not possible. So if you get absolute value bars by themselves equal to a negative, not possible. Okay, last one solution. All right, one solution. This is another tricky one. It's possible to get one solution when you have multiple x's, when you have an x on the inside of the absolute values and also on the outside at the same time. That's when it can kind of complicate things. Okay, so I know I'm trying to get the absolute value bars by themselves. So step 1, we got to add 2 over here. Okay, 3 times the absolute value equals 12x minus 24. So 3 times, so we're going to divide by 3. Divide everything by 3. So that's 4x minus 8 over here. Okay, absolute value box is by itself the absolute value of x plus 10 equals 4x minus 8. So step 1, we have the absolute value box by itself, complete. Now we need to split. Whatever's in here is equal to this. X plus 10 is equal to 4x minus 8. Or whatever's in here, x plus 10 equals the opposite of this, negative of that whole thing, parentheses 4x minus 8. Or if you want to think of it as opposite, as in change the sign of everything over here then. See, because it ends up being negative 4x plus 8. All right, solve. Okay, well, minus x, 10 equals 3x minus 8. Add 8, 18 equals 3x. Divide by 3. So we have 6. All right, what about over here on the other side? Let's see, I want to get positive x's if I can, so we're going to add 4x. 5x plus 10 equals 8. Minus 10, minus 10. 5x equals negative 2. Divide by 5. X equals negative 2/5 or negative 0.4. However you want to look at that. Okay, now it's always a good idea to double check your answers. We kind of walked through it on the first page here. We kind of talked our way through it. We didn't actually put it in, but we did. We talked about it, right? We said 3 times 2 is 6 minus 2. Okay, we went through that whole thing. Definitely want to check on these when you have x's everywhere. X's inside and x's outside. Okay, so if you need to pencil it out, you can, or we're just going to talk ourselves through it here. 6, okay, so let's put 6 in. 6 plus 10 is 16. Absolute value of 16 is 16. Times 3 is 48. Minus 2 is 46. Okay, so we're thinking 46. A little bit bigger on the other side. 12 times 6 is 72. Minus 26, 46. So that one checked out. That one checked out. 0.4. All right. 0.4 plus 10 is 10.4. Absolute value is positive 10.4. All right. Times 3 minus 2. 29.2. Let's see what happens with the next one here. 12 times 0.4 minus 26, negative 21.2. So that one's not going to work. Okay, no go over here, just this one. All right, how come that happens like that? Is when you got one of them on the inside and one of them on the outside, okay, and then you end up getting, you're going to end up getting some, that was negative 0.4, wasn't it? Yep, so we'll walk that back. It's still not going to work. We didn't do it correctly here. Negative 0.4. I didn't see my negative 2/5 there. Negative 0.4. So 3 times, nope, negative 0.4 plus 10. All right, it's 9.6 times 3 minus 2. 26.8, a little bit different. Not by a lot, but a little bit. All right, and then we have 12 times negative 0.4 minus 26. So when it's a negative, okay, why is it going to be different? All right, because when we do this over here and we do the absolute value, it comes out positive. And then when I put the negative over here, this is going to be a negative. 12 times the negative is going to be a negative. So that's the trouble here when you have x's on the inside and the outside. Because if you have a negative answer, it's really going to mess things up. All right, so that's why the 6 worked for both of them, because it was positive and kept this positive and kept that positive. And this one kind of messed things up a little bit, so we're not going to be able to use that one, just this one. Okay? So that's this video, guys. It's going to go with the notes. I'm also going to put in a secondary video on Schoology for you here. That's an older video that's not matching with these notes, but it might be a good kind of secondary video if you want something else to kind of like reinforce it. If you just want to watch a different set of notes. All right, so good luck, guys. Let me know if you have any questions.